Well, hello again, and welcome back to episode 014 of Code While. This is part two. You might not understand what's going on if you haven't seen part one, so feel free to explore that first. In this part of the episode, I'm going to cover some of the code in this first code section on this web page, which had some of the implementation of so-called class-based event listening for HTML elements in JavaScript. And the basic idea there is that instead of using add event listener or attach event for HTML elements, this code permits use of an add class event listener function to attach to an event listener to various HTML classes which correspond to the class attribute of HTML elements, which is a space-separated list. All right, so let me get into it here. The first thing I'm doing is I want this to be replayable code, so I'm checking to find out if this EP014 object for episode 014, if this object is undefined, then we'll establish it. Otherwise, it's already been established and none of this code in this section will do anything at all. All right, and what have we got here? Inside this funny looking business here is an inner code object, and it's got a variety of properties. The first one here is Boolean options. It's an array of arrays, and they're pairs. These subarrays are pairs with a name and a Boolean value. So the first one is capture with value false. Once is the next one with false, and passive with false. These are Boolean options that are relevant for the optional options object, which can be passed to modern implementations of add event listener. And because add class event listener in this code is trying to achieve equivalent or parity, feature parity with that modern feature, then I'm accepting the same complicated options object with these kinds of Boolean options, as best I can anyway. The next property is an entries object, which is empty by default, and a type counts object, which is empty by default. What is the purpose of these? The type counts object is going to keep track of the number of registrations for a particular event type. For example, click is a type of event, and so there will be a count of all registrations for the click event in this type counts object. Entries is a little more complicated. It's going to have properties which correspond to the class for a registration, the event type for the registration, and the phase for the registration. Each of those will be space separated, and that entire string will be a property of this entries object for each different kind of registration that matches those same arguments. All right, and next, moving on. Here is add class event listener is a property which is a function, and it's supposed to resemble add event listener from modern implementations of web browser JavaScript. But whereas those add event listener and remove event listener are called on HTML elements, instead this add class event listener is called for a class in place of where an HTML element would be. It's going to take the same 3 arguments as add event listener, but then this class name will be the first argument before those others. It's got variables entries underscore name entry, existing underscore entry, has as a convenience shortcut, and I for iteration. First thing it does is it invokes code.checkArgumentCount on the arguments. That's because it's going to be used in a couple of different places. So I've outsourced argument checking to that function. And assuming no errors are thrown from that, we'll get down to here, where entry is set up as an object with a single property so far, called class name, and it'll be set to the class name argument that was passed to add class event listener. Next, I'll invoke code.processCommonArguments, and I'll pass it that entry, and the type and listener and options arguments. And after that, that's going to populate entry a little bit further. It's going to incorporate some of this detail into this entry and establish it a little further. Then next, I'll invoke code.checkListener on the entry and the listener arguments. And if it returns false, I'm going to return. I'm going to do nothing. I'm going to return from this add class event listener. Now, what's the rationale for that? Well, in add event listener, if you pass null as the listener argument, what that is expected to do in modern documentation anyway, is it should exercise the options that you pass, but then when it comes time to finally attach a listener, it does nothing. Now, why do they do this? That's because getters and setters are modern JavaScript complications, and I suppose they're supposed to be convenient. And so passing along an options object that has getters and setters will allow you, a programmer passing an options object, to exercise your getters to at least find out how the implementation of add event listener explores your options that you've passed, whether or not it explores some of those booleans that we saw a little earlier. So that's what that's all about. So I'm going to do the same thing. I'm going to mimic that. I'm going to process the listener, find out if it's null, and then I'll do nothing. But I've already processed the options and exercised any getters that a programmer has implemented for their options object. Past that, if listener is not null, I'll establish entry's name as a concatenation of the class name, a space, the event type, a space, and the entry phase, which was gleaned from the options argument. And that is a sort of a build-up of a property that should appear in the entries object that I noted earlier. If that entries object does not have that entry's name as a property, then we will establish an empty array as that long-winded property name of the entries object. Furthermore, if this is the first time that an event listener is being registered for our event type, I'm going to make some extra accounting changes for that. If type counts does not have a property with the event type name, then I'm going to check whether or not this is a browser which has the add event listener function for HTML elements, or if it's a browser that has the attach event function for objects. So I'll support both more modern web browsers and some older web browsers. And if it's a modern web browser, I'm going to use add event listener to attach code.classEventListener. It's going to be the same function for no matter the event type for all event types to the document object of the web page. And I will attach it only for the bubble phase by specifying false here for the capture. And if it's an older web browser, I use attach event. It's a little bit different here. The event type has to be prefixed with on for on, like click would be on click. And then I'm attaching the same function no matter what. So what's the rationale behind this, attaching this to the document object? The way I'm implementing these class-based event listeners is first I'm going to wait for all event handling that exercises events registered with add event listener or with attach event. And after they've all completed and event listeners have had their opportunity to cancel the event handling or stop it by any other means, if it passes all of that and gets to the bubble phase and gets to the document element, then I'm going to start from scratch kind of thing or rework the event handling but from the perspective of these HTML classes as opposed to the elements. And so it'll have a capture phase and a target phase and a bubble phase, just the same as the phases that were exercised by add event listener for HTML elements. All right, and so I'm just attaching each event type once to the document element, and that's why I'm keeping track of the reference count of how many times a particular event type has been attached to the document, so that once it drops to 0, I deregister that event type from the document object. So I set that up as a, for example, click is an event type for the document object, and I'll set click as a property of type counts and set it to 0. So by this point, there's definitely a property for the event type in type counts, and I'll increment it by 1 because somebody has just attempted a new registration. All right, and then entries, I'll set to code.entries with the long-winded entries name, because that was established in the worst case right here as an empty array. And then here's a slow search. One of the documented behaviors of add event listener is that for a given combination of HTML element and event listener and phase, it won't re-register twice. So if that combination is the same, it's going to take no action. I'm going to do the same thing, but now this code doesn't deal with HTML elements in the same way. It's dealing with HTML classes. So what I'm doing is I'm iterating over the entries for that kind of registration, that combination, and I'm checking each existing entry from the array of the entries. And if the existing entries listener is equal to the listeners that was passed, then I'm going to return. I'm not going to do anything further. Otherwise, we get past that. This is a sort of a new combination for registration, and I'll push the built-up entry onto the entries array. Okay, and then here's check argument count. All it does is make sure that the count of arguments is within expectations, otherwise it throws an error. And check listener here is going to build up entry a little bit. So it takes entry and listener as an argument. I'm looking at the type of the listener argument. It's a little bit complicated with modern add event listener functions. Not only can you pass a function as an event listener, but you can pass a so-called handle event object. This is an object that has a handle event property, and that handle event property is a function. And when that handle event function is invoked, the this feature within that executing function will actually be the handle event object instead of an HTML element, which is maybe more traditional. So I'm checking for that and trying to mimic the same logic here. If the listener is an object, if it's null, I'm going to return we should do nothing further. The programmer has passed null. They wanted us to exercise their options, but there's nothing further to do. We're not actually attaching something. So I return false here. Otherwise, we get past that. I'm going to check if the listener.handleEvent property is maybe callable. A function would be callable, but some browsers also support objects, callable objects. So it might be the case that you have something you'd like to be the handle event property of a handle event object, but for whatever reason, maybe it's a browser built-in, a native function or something. For whatever reason, maybe its type of returns object instead of function. So I've used maybe callable to permit both sort of cases. If it's not callable, if it's definitely not callable, I'll throw an error that the listener object must have a callable handle event property. Then, getting past that, I'll set the entry's func property for function to be the listener object's handle event function. And I'll set up the entry's handler to be the listener, the handle event object, that is. And then we'll break out of this switch for that case. Otherwise, maybe the listener was a function type of value, in which case I set entry.func equal to that function, the listener, And I'll set entry.handler to null to indicate that we're not using a handle event object. That'll be useful for distinguishing later on during dispatch of event handling. And if it's not an object and not a function, I'll throw an error that it must be one or the other. After that switching of the type, I'll set entry.listener to be the passed-in listener, just to keep track of it altogether, because it's used for comparison right up here. When we check if the existing entry listener is equal to the listener that a programmer is attempting to register, then we drop out. We don't re-register it. So that's why I'm unconditionally keeping track of the listener that's passed in the entry as well. And I'll return true for that case. Now, this is for dispatching. I'm going to skip that for the next part of this episode 014. Derived from event, though. Here is a function that takes an event and a stop. I'm sorry, this is for dispatching also. I'm going to skip over that for now. And here's dispatch itself. And event listener deferred throw is also for there. I might as well cover the main function. Main is going to make an exports variable. It'll be an object, and it'll have add class event listener. This is something I want the programmer to have exposure to, access to. So it's going to come from the add class event listener function from this code object. And same with remove class event listener. It'll come from the code object. But then just for the sake of demonstration, if this was production code, I would not have this line here that has a non-production property for the exports. And what I'm doing here is, in case you'd like to explore it, I'm sharing the code object itself as this non-production property of the exports. And then I'm going to return the exports. So this is what's going to get returned to the programmer, just these two items in general. Down here, what I'll take a look at here, maybe callable. Here's maybe callable. I just check if the value is a function, or if it's an object that's not null, maybe it's callable too. Process common arguments takes entry, type, listener, and options. It's going to populate entry a little bit further too. Variables I, option underscore default, option underscore name. I'm going to check if the event type is not a string, then I'll throw an error. Otherwise, I'll assign that type to the entry as a property called type. Next, I'll check the type of options. This is where some of the complication comes in. Options is an optional argument for add event listener in modern implementations. But not only that, historically it could have been a Boolean. It was not only optional, but it could be the value false to specify that it's a registration for just the so-called bubbling phase, or it could be true to specify that it should be for a registration for the capture phase. So here I'm checking if it's undefined. The default sort of situation is that it's for the bubbling phase and not the capture phase. The capture phase is less frequently used in common practice. So I'm going to reset the options variable to be an object which has a capture property which is set to false, which is the default sort of situation. Otherwise, maybe the options was a Boolean, the false or true of yesteryear, you might say. So if that's the case, I'll reestablish options to be an object with a capture property where the value of that Boolean is the value of that capture property. Otherwise, if a real object was passed, it had better not be null. I won't support that, so I'll throw an error if that's the case. And otherwise, that's okay. We'll break out of this switch. And if it's a function, functions, like objects, can also have properties. Somebody might be doing something maybe unusual and passing a function that has the options specified as its properties, but I'll permit that. And the default case, if it doesn't match any of those cases, is to throw an error that it's an invalid options type. Then I'll iterate over the code.boolean options array of arrays from earlier. I'll get the option itself. It's a subarray of that Boolean options array. And the second element is the option default value, and the first element is the option name, and we saw those earlier. So for each one of those Boolean options, I'll check the type of the option name property of the options that we have from the programmer, if any. It might just be these defaults from a little bit earlier here. But otherwise, if the property has a type, and I'll look at the type. I'll look at that type and compare it. If it's undefined, I'll set the Boolean option's name as a property of the entry to be the option default value. Otherwise, if it's a Boolean, that makes sense. The programmer specified the Boolean. I'll copy the value. So they specified it here in the options, and I'll copy it to the entry. Otherwise, it's an invalid option, and an invalid type for the option, and I'll throw an error about that. Next, I'll take a look at the signal property of options. This is to permit a event listener to be canceled or aborted through an abort signal technique. I'll check if that signal, if its type is undefined, I'm going to replace it with a sort of a dummy object. That's an object that has an aborted property which is false perpetually. It won't make any difference. It just means that signal is not in use, basically. And otherwise, if the programmer passed an object for the signal property, if it's null, well, that's not valid, so I'll throw an error about that. But if it's an object or a function, because functions can have properties as well, I'll set the signal property of the options to be the signal property of the entry. And then we'll break out of that. Otherwise, the type is invalid, and I'll throw an error about that. It has to have the aborted property, for example. Then down here, I will we want to account for which phase this registration is for. So I'll take a look at the entry.capture that's been established by this point. And if it's true, then I'll set the event phase to 1 to represent the capture phase, and I'll give a phase property to the entry with the value of the name of the phase, capture. Otherwise, entry.capture is false, and I'll do the same thing, except this is to represent the bubble phase with the number 3 for the bubble phase, and the name is bubble. And I'll set that for the entry. And I'll also set entry.removed to false. The remove class event listener function, as we'll see in just a moment, is going to use this property here. So I set it to false by default. Then here's remove class event listener. Takes the class name, the type, the listener, and the options. And I'll ask for your forgiveness in the first part of episode 014. I misspoke, and I mentioned that some old web browsers had an attach event function and also had a remove event function. I meant to say detach event was the counterpart for attach event, or the opposite, I should say. So please forgive me for that. But in modern web browsers, the add event listener and remove event listener functions exist. And so this is remove class event listener, the counterpart for both detach event and remove event listener. All right, and what does it do? It's going to try to search for the listener registered for the particular phase, for a particular class, for a particular event type. And if it's found, then it will remove it or schedule it for removal. So I've got entries, entry's name, entry, existing entry, I. Those seem familiar from the add class event listener. I'll check the arguments the same as before. Pardon me. I'll set up an entry the same as before. I'll process the arguments, the common arguments, the same as before. And I'll check the listener the same as before to permit it to be null and to drop out early. And I'll build up the entry's name string for it. And I'll check if code.entries has that entry's name. If it doesn't, then this listener has not been registered, and I'm just going to return. And that's the same case for remove event listener and add event listener. They don't give much in the way of feedback. They don't have a return value. They just return. So I'm just going to mimic that and do the same thing here. Otherwise, there is a registration with some of that same combination. And so I'll fetch it from the code.entries and store it to entries. And I'll do a slow search through each one of the entries in the array. I'll get the existing entry. I'll check if the existing entry's listener is not equivalent to the current listener. Then we'll skip on to search the next entry. Otherwise, it is, so it's time to remove it. And I'm going to use the splice technique for arrays to remove this element from the array. And that'll effectively deregister the event listener from future event handling duties. And I'll also set its remove property to true, because if this occurs during event handling, it'll already be the case that these entries will have been copied and scheduled in a linked list. And so I want to permit them to be aborted or removed during event handling as well. And so that's what this removed property is for. I set that to true so that they can be detected and skipped. And if the entry's length after splicing that array, if the entry's array's length is not equal to 0, then I'm going to break out of this loop because there's nothing further to do. The registration has been removed, and that's good enough. But if the entries array has reached 0, there might be more cleanup that we can do. So I can delete the entries name combination from the entries object and clean that up. And furthermore, as the event listeners for a particular event type accumulate and are deregistered, that count can drop to 0 as well. So earlier I'd mentioned that let's take for example the click event. You could register 15 registrations for the click event, and those all go onto the document element, but not individually, just monolithically, one event registration on the document element. So here I'm going to check if it's if after this deregistration, if the count is 0 or less, then we can clean up by detaching that type of event listening from the document object. And that's what this does here. Take a look at the event type as a property of the type counts in the code. And if the count is less than 1, then I'm going to check whether or not the document supports remove event listener. And if not, it uses detach event. So I'll use one or the other, document.remove event listener or document.detach event, to remove the class event listener from the document for that type of event. And I will clean up the type counts as well for that type of event and just eliminate the property so that it frees up the memory that's used for that. And then I'll also break out of the loop because there's nothing further to do. We matched an entry, and that's that. Okay, I think that's probably it. So I hope you'll join in again for the part 3. And take care.